Okay, so this is the next one we're going to work on. Now, I started doing these fairly quickly. Let's take a look. The only thing we need to know to be able to do this is what we learned in the previous chapter or the previous page, and that was the limit as x approaches 0 of sine x over x equals 1. That is king. We're going to use that to try to solve some of these. So this one, I don't know what sine x over 2x is. I do not. I know what sine x over x is. So what I'm going to do is try to get rid of that 2. I'm going to treat it like a constant. Okay, take a look at that. Top times top, bottom times bottom. I go to the sine x over 2x. This constant can be taken out of the limit. Because of the work we did on the last page, we know a value for that. That equals 1. Which means that this limit here, as x approaches 0 of sine x over 2x equals 1/2. Oh, maybe something I should have mentioned before. Look what happens when I try to put in 0. Sine of 0 is 0. 2 times 0 is 0. We get indeterminate form. So that's a problem. That's why we needed to do more work. Let's take a look at this one. Let's allow x to approach 0. So it's 7 times sine 0. Sine of 0 is 0. Over top of 0, you're going to end up with the indeterminate form. So we need to do some more work. This 7 here is a constant. All I'm doing is trying to create a situation where I have the limit as x approaches 0 of sine x over x. Why? Because that's what I know. I know that it equals 1. So the 7 is a constant. It can come out. This we've worked out already. We know that that's going to equal 1. So it's going to equal look at the next one. This one's different. This one, I've got sine of 5x over 5x. Something you need to know right away is that sine of a to the x does not equal a sine x. It doesn't work that way. Sometimes we'll get lucky, but in general, that doesn't work. So in this case, I've got sine of 5x over 5x and only an x here. Notice that's different than our pattern. This was sine of x, and x approaches 0. You do understand at this point, I hope, that it wouldn't matter if I used x's or any other variable. Limit as a approach 0 of sine of a over a would equal 1. Do you see the same pattern? A, and a approaching 0. It wouldn't matter if we used, I don't know, I'm trying to think of another variable. B, there you go, 2b, there you go. 2b approaches 0 would be sine of 2b over 2b. We have the same pattern. 2b, so if you then said let 2b equals x, look what would happen. Limit as x approaches 0 of sine x over x, which is 1, which means that equals 1. So, looking here, I want to make this sine of 5x over 5x, and I really wish that this was a 5x. Well, notice there's no difference in saying x approaching 0 and 5x approaching 0, because as x approaches 0, so does 5x. So in essence, there's no real difference in me saying 5x approaching 0 of sine 5x over 5x. I haven't changed the question here. Notice that I've created this pattern, however. So if I wanted to, I'm noticing that it's sine of a over a as a approaches 0, or sine of x over x as x approaches 0. In either case, That's going to equal 1, which leads us to this theorem, which basically says that if you've got a value, sine k of x, where k is any value, over top of k of x, as x approaches 0, it's always going to equal 1, because I can always do this trick, because always, as x approaches 0, kx will also approach 0. Okay? All right, down to the next one. Now this one's different. I've got a 9, but I don't have a 9 down here. I don't have this pattern. The 9's not in the bottom. So I'm going to do something to get a 9 in the bottom. I'm going to multiply it by 9 over 9, which is equal to 1. Now if I think about this, this 9 in the bottom I want to keep. So it's going to be 9 times sine 9x over top of. So look at that. That's how I want to have that. Top times top, bottom times bottom. This is a constant in the top. Take that out to the other side. This is a good thing. Look what I did. 9x and 9x. Looking back at this, so if it's sine of 9x over 9x and x approaches 0, remember x approaching 0 is the same as if 9x was approaching 0. So this whole thing is going to equal 1. This whole thing. But remember you had the 9 on the outside, so it equals 9. Notice that this is a theorem saying that if this pattern ever happens again, and if you remember the theorem, you can just simply say that it'll equal k. For me, I'll probably go through the argument. I won't use the theorem, but there is a theorem there to be used if we want to.